So this is what I get on my laptop when I punch this in. If I wrote that for an answer, I'd be in big trouble. No, that doesn't fix it because it's the fraud, it's the deception of my number. If I leave it as a fraction, it's 50 over 21. I don't know how accurate that number is. This shows it with 16 significant figures. That would cost me, I don't know, $10 billion to get that kind of significance. I don't know if we humanly can get that kind of significant figures. So obviously I have to write it as a decimal to show how accurate my number really is. So if you see this DD on a test, that means digital diarrhea. I don't count off for it really. First packet 1 or packet 2, I probably will start counting off for packet 3. Accuracy is important. You've got to be honest with what your instruments can tell you. So if you said the answer was 2 meters a second, that'd be like a best guess. Like I don't know, it's about 2, how long it take you? How fast you go? I don't know, about 2 meters a second. That's like a slow jog, okay? But that's not going to do it in our class. So if you go a little bit further, say you have a cheap stopwatch, and you caught him when he started, or she, and then maybe you're waiting at the finish line, or somebody else was, and you start stop 2.4 is a cheap stopwatch. 2.38, that's a typical iPhone or a watch, Galaxy, whatever watch phone you would use, and the stopwatch on there. If it shows it to 3 significant figures, that's the best you're going to do. It's not because of the watch, it's because of your human reaction time. We'll do a lab on that later on. Okay, if you have it at this one, if you're at this far, then you got a very expensive start, some kind of start, stop, finish, where the person broke the plane of the start and then broke the plane of the finish line, and you had some kind of electronic device. And if you go any further than that, if you go 2.3810 for your answer, that requires photo gates. So now you're really getting into some big expenses. So that's probably about as far as we could get it, and probably you would in college. Now in grad school, maybe go a little further, but all of this, it's just to say that you don't leave things in terms of fractions unless they're a coefficient. Now a coefficient is mathematical. It comes from just the math equations. And those have infinite number of significant figures because they're not measured. But measured numbers have to have units. Coefficients don't have units, but measured numbers have to have units. So let's say any number with unit needs to have significant figures. You need to consider how many digits you're giving me. Typical, if there's not really if you don't know, if it's just a problem written out, you can give it to me like 3 digits. 3 digits is always fine. Sometimes just 2, but never 1. 1's always too general. You'll never have 1 significant figure. You might as well not do the lab. So at least 2 or 3. Occasionally you got to go out to 5, but you'll see the reason why on those problems. But I'll take 3. 3 is a good solid number. Always give me 3 digits. Now we haven't even talked about what is necessarily significant, what isn't. If it's a non-zero number, it's significant. It's a number you would include in your significant digits. If there's a 0 involved, that's where it gets tricky, because if I say the number 2,000, that has 1 sig fig. You go, well, shouldn't 2,000 have 4? If I say 2,000, that has 1 siggy. If I say 2,000.0, that has 1, 2, 3, 4, 5 sigs. Okay, I don't want to get into this yet. I mean, this is coming later. Just a little preview, but just in general, don't give me this digital diarrhea. I'll be happy if you just don't do that. This during packet 1. Okay, thanks.